All right, good afternoon. I got an email requesting explanation of number 17 and number 19 from some of the work that was assigned last week. And they're good problems to go over. They're very good examples of conditional probability and the multiplication rule. So we'll take a look at number 17 first. In a box of 11 parts, car parts, stereo parts, whatever they are, box of 11 parts, 4 parts are defective. 2 parts will be selected at random without replacement. So that's very important. 2 parts are selected at random. That means 2 events have to occur here. And any time you're going to have events occurring in sequence, one thing happens and then another thing happens, that's an indication that we're going to use the multiplication rule. So we're going to have to find the individual probabilities of each event and multiply those together, keeping in mind that the first event may affect the probability of the second event occurring if they're dependent events, which in this case, because of this phrase here, without replacement, tells us that there is going to be something dependent going on here. So we'll take a look at this. I've already put this information over here into, let me get out of that. I'll need to switch. Oh, maybe it won't let me do that here on the Screencastify. That's a problem. Oh, I need to exit this edit. There we go. Now we're good. Should be good. There we go. Defective parts. Again, 11 parts, 4 are defective, 2 parts are selected. Find the probability that both parts are defective. So in this case, we're going to have 2 events. Event 1 and event 2. So box, 11 parts in it, 4 are defective. What's the probability that the first part is going to be defective? Very simple fraction. Total number of parts is 11. 4 of them are defective. The probability of picking a defective one is going to be 4 divided by 11. And we'll do that division here. It'll give us an answer. Now, we have not replaced that one. It's taken out. So we have to consider there's not 11 parts in the box anymore. There's now only 10 parts in the box. And we took a defective one out. So instead of 4 defective ones, there's actually 3 defective ones. So our probability for event 2 is now 3 divided by 10. And of course, because we're doing a multiplication rule, our final probability is going to be those 2 answers multiplied. And that gives us 0.109 as an answer, which we can see is the correct answer from the textbook. Part B, find the probability that both parts are not defective. Again, 2 events. The first event, 11 parts is our total. We know that. How many of them are not? Well, 4 are defective. So obviously 7 will not be defective. So we're going to have 7 divided by 11. And secondly here, now we have event 2. We've taken one out. We've taken a good one out, which means there's now only 6 good parts remaining out of 10 parts total. And finally, our final probability answer is going to be to multiply those 2 numbers together. Equals that cell times that cell. 0.382, if we round it off, which again is the correct answer. Now, letter C, find the probability that at least one light bulb, or I'm sorry, I'm thinking of a different question. At least one part is defective. Now, in this case, it helps to think about your sample space and think about all your possibilities, okay? We can get 2 good parts, right? Good part and a good part. We could get a good part and a defective part. We can get a defective part and then a good part, or we could get 2 defective parts. And this is the only 4 possible outcomes total for this situation because it's a very simple problem. So think about it. At least one part is defective. Well, if we get 2 defective parts, that meets that criteria of at least one. If we get a defective one followed by a good one, Again, it meets the criteria of at least one defective. If we get a good one, then a defective one, again, it meets the criteria of at least one defective. Now, you could find those three probabilities. Good part, 7 out of 11 times 4 out of 10. This would be 4 out of 11 times 7 out of 10. This would be, we already did this one in part A, this would be 4 out of 11 times 3 out of 10. You could add those three probabilities up. But the simple thing to realize is that this is the only unacceptable solution to this problem. Right? These other three here would all be considered acceptable solutions. So instead of doing three probabilities and adding them up and spending the time to do that, recognize what doesn't fit and just subtract that from your answer. And we already found the probability of two good ones back here in part B. So our answer for part C is going to be 1 or 100% minus that answer. That's going to give us the 0.618, which is the correct answer here in the textbook. So I hope that clears up number 17. Now we'll move on to number 19. Number 19 is a conditional probability question. It's one of these two-way tables. Talks about emergency saving. Table shows the results of a survey of 142 men, 145 women. Workers, 25 to 64, asked how much income they had set aside for emergencies. They broke it up to people who had less than 1 month's income and people who had more than 1 month's income. Letter A says, find the probability that a randomly selected worker has 1 month's income or more set aside for emergency. There's no conditional. There's no given that. We're talking about all of the workers out of the total. So we're looking at, I'll hop back over here to the table. 1 month income or more saved. 1 month income or more saved was 76 men, 62 women, 138 people total out of 287 people total. We'll type that in, equals 138 divided by 287, and that's 0.481, which is the correct answer. Very good. Second question says a randomly selected worker has less than 1 month's income saved given that the worker is male. That means we're only looking at the men in this study. So, only looking at the men, 66 had less than 1 month income out of 142 men. So we'll type in equals 66 divided by 142. You get 0.465. Let's double check our answer here. 0.465 is correct. Given that the worker has 1 month's income or more saved, so we're only looking at the 1 month income more saved, so now we're looking at this row across. Find the probability that the worker is female. 1 month's income or more, 62 out of 138 should be our correct answer. .449, double check. 0.449. The last question is one that requires you to think. Are the events of having 1 month's income and being male dependent or independent? In other words, does one affect the other? Well, here's a simple way to think about this. Let's look at 1 month's income or more. 138 divided by 287, which is what we did back here in letter A. We said, okay, 138 divided by 287 is 0.481. Okay? As soon as we got to part B, okay, or let's look at it this way. Let's strictly look again at the 1 month's income or more. We know if we look at all the workers, we know we have, that's the 138 divided by 287. And we know that that equals, type it in here again, 38, because sometimes it's helpful to look at the decimal, 287. Okay, we have that decimal there. If we look at just the men, okay, 1 month's income, we say 1 month's income, just looking at the men, is 76 divided by 142. So we type that in, type it in, 76 divided by 142 42, first we'll put it in as the fraction, and we'll do it as the decimal. We get 0.5352. The probability changed. As soon as you added the condition that the person is a man, the probability changed, okay? If we do it in the reverse and we think about, okay, well, let's look at 1 month's income and as the conditional, okay, and then we say, okay, 142 out of 287 versus 76 out of 138, we would again see a change in the probability. So the bottom line is when you look at the two things together, the difference between all workers and the condition that they're a man or the condition that they have 1 month's income, as soon as you add a condition, it changes the probability outcome. If the probability outcome changes, then the bottom line is it has to be dependent. Anytime if things are going to be independent, then this decimal here, 0.481, that would not have changed when we added the condition that it's a man. Okay, so that's an easy way to test and see if something is dependent or independent, is to see whether there's a change in the probability from one event to the next, or when you add a conditional statement. So I hope that clears up those questions, and enjoy the rest of your day off today. It's Monday, it's an in-service day. So have a good day.